Have you encountered a situation wherein you want to know if the claim was right or wrong?
No need to worry because in this lesson, we will tackle hypothesis testing for comparative analysis, although we'll just cover steps 1 to 4.
What is hypothesis? Hypothesis is an educated guesses that may or may not be rejected.
But what is hypothesis testing?
It is the statistical procedure of drawing conclusions that generally pertains to the characteristics through a population of sample data.
And here's how we'll be able to properly conduct the hypothesis testing using the 7 steps. But again, we'll just cover the first 4 steps.
Step 1. Formulation of null and alternative hypothesis. Step 2. Select the level of significance. Step 3. Determine the test of statistics to use. Step 4. Define the area of rejection or the critical region. Step 5. Compute for the value of this statistical test. Step 6. Decision. Reject HO or not to reject HO. Then cite the level of significance used in the study. Step 7. Interpretation or conclusion.
Step 1. Formulation of null and alternative hypothesis.
Let's first know what is null and alternative hypothesis. Null hypothesis is denoted by the symbol HO. It refers to any claim about the parameter of population and the hypothesis that is intended to reject in conclusion. While the alternative hypothesis is denoted by the symbol HA and the claim that contradicts the null hypothesis.
Let's take a look at this example. Telecom service provider claims that individual customers pay an average 400 pesos per month with a standard deviation of 25 pesos. A random sample of 50 customers' bills during a given month is taken with a mean of 250 and standard deviation of 15. What to say concerning the claim made by the service provider? The service provider is 95% confident in its claim. Let's first set up the hypothesis with its symbolic form. But how?
Let's look at this table of symbolic form. Their hypotheses are always opposite of each other. But here's the catch. Always remember that HO must have an equal sign. So if the claim of the HO doesn't have an equal sign, HO and HA symbolic form will interchange. For that, we will use the accepted symbolic form.
Going back to the problem, let's now set up the hypothesis. The null hypothesis or HO will be mu equals 400 and indicates that the average monthly bill for individual customers is 400 pesos, while the alternative hypothesis or HA will be mu is not equal to 400, indicates that the average monthly bill for individual customers is not 400 pesos. Let's now identify whether it's one or two tailed tests and whether it's one or two mean tests.
To be able to know whether it's one-tailed or two-tailed, just look at your symbolic form. It's always two-tailed if your symbolic form have an equal sign. If it's not, then it's one-tailed. And to identify whether it's one mean test or two mean tests, just like it said, if you have one mean, then it's one mean test. And if you have two mean, then it's two mean tests.
Which means, in our example, we have two tailed tests and a one mean test.
Let's now proceed to step 2. Select the level of significance. In a word problem, you may encounter the level of significance itself or a level of confidence. Level of significance is the degree of uncertainty, denoted by the symbol can be 0.01, 0.05, or 0.10. In percentage, it is 1%, 5%, and 10%, while level of confidence is the degree of assurance and can be 0.99, 0.95, or 0.90. In percentage, 99%, 95%, and 90%. If you encounter the level of confidence, just use the equation. Let's take a look of our example. As you may notice, we have a 95% as a level of confidence. It's not a level of significance. Using the equation, we will subtract the 0.95, decimal form of 95%, to 1, giving us the level of significance of 0.05.
Next is the step 3. Determine the test statistics to use. In this step, we have two choices to choose from, the z-test and t-test. If we have a sample size that is more than 30, we will use the z-test. But if it's less than 30, we will use the t-test. To further elaborate what test we will use, well, you can refer to this flowchart. First, ask if your variance is known. If yes, use the z-test. If no, then ask if your sample size is more than 30. If this time you answer yes, then use z-test. If it's still a no, you can now use the t-test. Now, let's take a look at our example. To be able to find the critical value in the next step, let us know the test statistics that we will use. Knowing that our sample size is 50, and we know the population standard deviation, then we will use the z-test.
For the last step, we will tackle step 4. Define the area of rejection or a critical region.
First, let's define what is the area of rejection. This is also known as the critical region. It is the area under the normal curve in which the null hypothesis is rejected. But how do we know where the non-rejection or critical region stops? Using either Z or T test table, we will be able to find the critical value, the area that separates the area of rejection and non-rejection region.
For the last time, let's look again at our example. Earlier in step 1, we have identified that our problem was a two-tail test, which indicate that both tail of our normal curve will have a critical region and there will have a negative and positive value. Using one of the C and T test table, we will find the critical value. In our case, we will use the z-test. Looking at the 0.05 level of significance in the two-tail test, we will have a positive negative 1.96 critical value. Therefore, we will have reject the null hypothesis if the computed value is greater than positive 1.96 or less than negative 1.96. Otherwise, do not reject the null hypothesis. This is only for two-tail test. So, how about the one-tail test?
One-tail test. Only one side of the under the area. Normal curve will have a critical region. Position, it's on the right side. The negative, it's on the left side. Student A and B owned a small coffee stand called Brew. They are famous for their classic brew, and one of them suggested that they want to add another coffee on their menu called roast harmony.
Can we add another new to the menu? I'm kinda sick of making classic brew all day. And don't worry, I already made some experimentation and led me to make this one, the Rose Harmony. Here, try it.
It's nice. Okay, then let's put this in our menu.
Once the roast harmony coffee was on the menu, it's starting to catch up with the classic brew.
Gosh, I didn't know your Rose Harmony will be this popular.
Yeah, but many people still prefer the classic brew.
I know, but it's nothing compared to my Rose Harmony.
Well, should we put this to the test? Let's see if the Rose Harmony of yours is more preferred by our customers than the classic brew.
Well, I'm 95% confident it will.
So they conducted this study to evaluate this split by comparing customer rating for the taste between Rose Harmony and Classic Brew. They randomly selected 25 customers who tasted both Rose Harmony and Classic Brew. Each customer rated the taste of both blends on the scale of 1 to 10. At the end of the day, they have gathered their scores. For the Rose Harmony, sample mean rating equals to 8.5. Sample standard deviation equals 1.2. For the Classic Brew, the sample mean rating equals 7.8. Sample standard deviation equals 1.5.
First step, let's formulate our hypothesis. But first, let sample mean number 1, rating of Rose Harmony, and sample mean number 2, rating of Classic Brew. With this, we can formulate that HO, the average customer rating for Rose Harmony, is higher than the average rating for Classic Brew. And the HA is, the average customer rating for Rose Harmony is the same as or lower than the average rating for Classic Brew. But, oopsies! We mentioned earlier in the step 1 that HO must always have an equal sign, so we need to interchange. Now, we'll have a null hypothesis, stating that the average customer rating for Rose Harmony is the same as or lower than the average rating for Classic Brew, and an alternative hypothesis that states, on the other hand, that the average customer rating for Rose Harmony is higher than the average rating for Classic Brew. And now, let's identify the tail and mean test. It is quite evident that we have two mean tests because it has two means. And for the tail test, we have a one-tail test since the symbolic form are not just equal sign. Step 2. Select the level of significance. It is stated by student B that he has a 95% level of confidence. So by that, we will use 1 minus A to get the level of significance. 1 minus 0.95 is equals to 0.05, which means our level of significance is 0.05. Now, let us proceed to step 3, determining the test of statistics to use. We have a sample size of 25, which means we will use the t-test. Now, using the t-test table, we first need to identify the DF by subtracting the sample size, which is 25, to 1, giving us the answer of 24. Along the row of 24, and knowing the level of significance for one-tailed test is 0.05, then we have a t-value of 1.71. Now, for the step 4, defining the area of rejection. Knowing from the previous step, we have 1.71 as our critical value, but in which site? Since in our HA has a symbolic form greater than from the hypothesis we formulated earlier, then our critical value will be positive, indicating that it's on the right side. Regardless if we only tackle the first 4 steps, we still must proceed to prove the claim. So, in step 5, We just need to solve the case 1 t-test equation for two independent means. 8.5 minus 7.8 divided by square root of 1.2 squared over 25 plus 1.5 squared over 25. Typing this in science calculator will give us an answer of 1.82. To make a decision, let us now proceed to step 6. Since the computed t-value, positive 1.82, is greater than the tabular value, positive 1.71, therefore, reject the null hypothesis at 0.05 level of significance.
So, which means the Rose Harmony was a hit than the classic brew.
Well, I guess you're correct.